Let's start with the review for the final test. So the first example, write the standard formula equations of the circle with the given characteristics. End point of the diameter is 2, 2, and 12, 2. So we have circle with end point. Here's the diameter. We have 12, 2, and the second point is 2 and 2. So these are the end points. So the first step I'm going to do, I'm going to find the diameter, which is by using the distance formula. So the distance formula, this is number 1, is going to be x2 minus x1 squared plus y2 minus y1 squared. So the distance formula is going to be, I'm going to say this is x1, y1, and x2, y2. So it's going to be x2, which is a 12 minus 2 squared, plus y2, which is 2 minus 2 squared. That means the distance is going to be 10 squared plus 0 squared. And it's going to be 10 squared is 100 plus 0. And it's going to be the square root of 100, and it's going to be 10. So the distance between these 2 points is 10. We need to find the radius, which is the half of the distance. That means our radius is going to be 10 divided by 2, and it's going to be 5. Now, the second part on this equations, we don't know the center because we need to write down the equations of the circle. So we need to know the center, which is the midpoint between these 2 points. So I'm going to use the midpoint formula, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And it's going to be x1, 2 plus 12 divided by 2, and 2 plus 2 divided by 2. And it's going to be 14 divided by 2, and here's going to be 4 divided by 2. So our center is going to be 7 and 2. This is the h, and here's the k. That means the equations of the circle is going to be x minus h squared plus y minus k squared equal r squared. So it's going to be x minus h is 7 squared plus y minus k, which is 2 squared equal 5 squared. So it'll be x minus 7 squared plus y minus 2 squared equal 25. So our solution is supposed to be one of these, which is going to be x minus 7 and x minus 2. So it's going to be E. So we're going to choose E for the first one. For number 2, we have the center is 6, 1, and the solution point is 5, 9. So for the second one, we have the center, which is 6, 1. That means this is H, and here's K. And we have solution point, which is equal 5, 9. So 5 and 9. So let's write down, we need to find the equation of the circle. So the equation is x minus h, the standard form, plus y minus k squared equal r squared. We don't have the radius. We have the center and we have solution point. The solution point is the xy. That means x is going to be 5 minus h, which is 6 squared, plus y. Y is, the point is 9 minus k, which is 1 squared equal r squared. So it's going to be -1 squared plus 8 squared equal r squared. That means it's going to be 1 plus 64 is going to be equal r squared. So it's going to be 65 equal r squared. That means r is going to be square root both sides. It's going to be square root of 65. So the standard form of the circle is going to be x minus 6 squared plus y minus k, which is 1 squared equal 65 squared. So it's going to be 65. So that's it for this example. So we're going to choose x minus 6, x minus 1 equals 65. So it's going to be D. For number 3, we need to find the domain. For f of x equal 2x squared plus 4x minus 5. So the domain for this one is quadratic equations. The parent function for the quadratic equations, which is x squared. So if you want to derive the basic function, which is x squared, the graph of the basic function is like this. The domain is negative infinity to positive infinity. So the domain for any quadratic equations, negative infinity to positive infinity. So I'm going to choose all numbers. So B, all real numbers. That's it for example 3. For number 4, find the domain of the function. It's a rational function and there's a radical on the top. So to find the domain, I'm going to take the denominator on the side. So I'm going to say 4 plus x not equal to the 0. That means solve this one, so x is not going to be equal to -4. That means I can choose all numbers except -4, because when you plug in -4 here, the denominator is going to be 0, and you can divide by 0. But we have radical on the top, so I'm going to take everything under the radical greater than or equal 0. That means x greater than or equal -4. So this is for the radical. We need to combine these together. So x not equal to the -4 and x greater than or equal -4. We can't include the equal sign because we can't equal -4. So the domain in this case is going to be all x value such that x is going to be just greater than -4. So this is the domain. We can choose all x value greater than -4 because we can choose equal -4. And we can choose the -3, -5, -6, because when you plug in here, it's going to be negative number, and the radical for negative number is going to be complex number. So that's it. For this example, we're going to choose all x value greater than -4. So it's going to be C. For number 5, use the graph to find the domain and the range. The domain is going to be all x value. So let's check here. The function is for x value from negative infinity until this point, which is -4. So the domain is going to be from negative infinity until -4. And then start again, it's an open circle. Start again from union, again from -4 to infinity. But look to the range for this function. The range starts from negative infinity from this point and keep going until -1. So from negative infinity until -1. This is the range, union. And then the function doesn't start again from -1. It starts from 0. So from 0 to infinity. So this is the domain and the range for number 5. That's it for number 5. For number 6, use the vertical line test to determine in which the graph is not a function. So A, they're telling you all choices. Let's check B. B, we need to use the vertical line test. So if you graph a vertical line test here, you will see at x equal 2 goes to 1 and 2. So when x equal 2 goes to 2y, that means we found a person going to 2 location, which is impossible. So that means this is not a function. Let's check the rest. So the first one is not a function. Let's go to the second one. So this one is not a function because we found one person going to 2 locations, 1x going to 2y. That means this is not a function. So I can't choose this one. Let's check the second one. If you graph a vertical line test here, 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 you will see this x going to 1y. If you graph a vertical line test here, you will see this x going to 1y. If you graph a vertical line test here, you will see this x going to 1y, which is here. So this is a function because each x going to 1y. The same thing with this graph. If you graph a vertical line test here, you will see this x going to 1y. That means this is a function. So that's it for this example. The only one we have to choose is B is not a function. For number 7, determine the intervals over the function increasing, decreasing, or constant. We have this graph and we need to check it's increasing, decreasing, or constant. If you look to the first part here is constant. Let's prove that. So I'm going to choose 2 points here, this one, and here is the second point. Any 2 points, any 2 points from the graph. So for number 7, I'm going to choose 2 points. The first one is x is -2 and y is 1. And the second one is x is -1 and y is 1. So x1, y1, x2, y2. Find the slope, which is y2 minus y1 over x2 minus x1. So it's going to be y2, which is 1, minus y1 is 1, divided by x2 is -1, minus x1, which is -2. So it's going to be 0 divided by -1 plus 2 by 1 is going to be 0. That's why from negative infinity to this point, from negative infinity to this point, which is 1, the function is constant. So of the domain from negative infinity to 1 is constant. Function is constant. Let's check from 1, which is, you see there is a closed circle, so it's going to be closed. But from 1 to where is going to be increasing. Let's check that. If you look to the graph, it's decreasing. But let's check that. We're going to choose 2 points. You can choose this one which is 1, 2, and you can choose this one. So I'm going to choose these 2 points. So I'm going to choose the first one is 1 and y is 2. And the second one, I'm going to choose x is 0. Sorry, x is 3 and y is 0. So here's x1, y1, x2, y2. So the slope is going to be y2 minus y1 divided by x2 minus x1, which is going to be y2 is 0 minus y1 is 2 divided by x2 is 3 minus x1, 1. So it's going to be negative 2 divided by 2, which is negative 1. We got negative slope. That's mean from 1 to infinity is, from 1 to infinity is decreasing. That's it for this example. For example 8, we need to solve the inequality. The inequality is x minus 4 squared greater than or equal 1. So the first step, we need to find the critical numbers. So if we need to solve this one, we're going to divide both sides, take the square root for both sides. The square root for x minus 4 squared greater than or equal the square root of 1. So cancel this one with the root. So it's going to be x minus 4 greater than or equal plus or minus 1. I need just to find the critical numbers. If you want to convert this one to equal sign and solve it, or keep it the greater than or equal, solve it, it's the same thing. So now solve this one. That's mean x minus 4 greater than or equal. Let's put negative 1 here. And x minus 4 greater than or equal 1. Solve this one. You're going to add 4 to both sides. That's mean x greater than or equal 3. Because it's going to be 4 minus 1. And here's going to be x greater than or equal. Move this one to this side. It's going to be 5. That's mean my critical numbers is going to be 3 and 5. I'm going to put the line here. Here's the 3. And here's the 5. Now I need to check the interval. This one goes to negative infinity and this side to positive infinity. So I'm going to pick a numbers. Let's pick a number here, which is less than 3. Let's take the 2. If you plug in 2 here, it's going to be 2 minus 4. So it's going to be 2 minus 4 squared greater than or equal 1. That's mean negative 2 squared greater than or equal 1. That's mean 4 greater than or equal 1. That's mean this one is interval solution. Let's take number between 3 and 4, 3 and 5, which is 4. If you plug in 4 here, it's going to be 4 minus 4 squared greater than or equal 1. 4 minus 4 is going to be 0. Greater than or equal 1? No, this is wrong. That means this is not a solution. Let's take the 6 on this side. Let's take the 6 here. So plug in the 6 here is going to be 6 minus 4 squared greater than or equal 1. 6 minus 4 is going to be 2 squared greater than or equal 1. 4 greater than or equal 1. That means this is a solution. So that's mean our solution, be careful, there's equal sign and equal sign on both sides. So it's going to be from negative infinity to 3. And we're going to put a bracket on this side, union, another bracket from 5 to infinity. So here is our interval solution. So we're going to choose, in this case, we're going to choose B, because this is exactly like B. That's it for example 8. For example 9, they ask you to solve the equations. For this one, we can solve it by using like AC method. You're gonna open two parentheses. We can't factor it. We have to use the quadratic formula. So A in this case equal 1, B equal 10, and C equal 29. The formula says X equal negative B plus or minus square root of B squared minus 4AC divided by 2A. So we're gonna plug in X is going to be equal negative B is 10 plus or minus square root of B squared is going to be 10 squared minus 4 times A is 1 times C is 29. And everything divided by 2 times A is 1. So X in this case is going to be equal negative 10 plus or minus square root of 10 squared is going to be 100 minus 4 times 1 is going to be 4 times the 29 is going to be 116 divided by 2 times 1, which is 2. So I have to write down 2 here, 1 anymore. This means here is 2. So this one is going to be equal negative 10 plus or minus square root of 100 minus 16 is going to be negative 16. And everything divided by 2. That means X is going to be equal negative 10 divided by 2 is going to be, gonna write it down, plus or minus the square root of negative 16 is 4, and the negative sign is going to be I divided by 2. In this case, X is going to be equal to negative 5 plus or minus 2I. So that's it for this example. We have two solutions. We have negative 5 plus 2I, and we have negative 5 minus 2I. That's it for this example. So we're going to choose, in this case, for number 9, we're going to choose negative 5 minus 2I and negative 5 plus 2I. So it's going to be D. For example 10, we need to simplify the radical expression. So let's check how I'm going to solve this one. The first thing is multiplication. So I'm going to write down this one is equal the fifth root of 192 times the fifth root of x to the power 6 and times the fifth root of y to the power 7. Then we can convert this one to rational exponents. So if you want to keep it as a radical, it's fine. If you convert it to the rational, it's fine too. Now let's check to 192. 192 is 64 times 3. Or I can write down 192 is 32 times 6. 32 is 2 to the power 5 times 6. So I'm going to simplify this one. I'm going to say it's the fifth root of 2 to the power 5 times 6. For the x, I can write down the x as a fifth root of x times x to the power 5. Because when you multiply these, the same base, you're going to add the exponents. It's going to be x to the power 6. The same thing for this one. We're going to say it's y squared times y to the power 5. And here's the fifth root. Now, this one with this one is going to cancel. or if you convert it to the rational exponents, is going to be 2 to the power 5 times 6 to 1/5. And here's going to be x to the power 5 to 1/5. And here's going to be y squared, y to the power 5 to power 1/5. That's mean here is going to be 2 5/5. And for the second one is going to be just 6 to 1/5. And for the x, this one is going to be x to the power 1/5. And here is x to the power 5/5. And the same thing for the y. Just want to show you 5/5. The same thing for the y is going to be y squared, or y to the 2/5. And here's going to be y to the power 5/5. So this one is going to be 2, this one is going to be x, and this one is going to be y. So it's going to be 2xy. Here is the left. No, not this one. Let's put these together. So it's going to be 6xy squared to the power 1/5, which is mean this one is going to be 2xy, and here is going to be square root, or fifth root, sorry, to the 6xy squared. So this one is the solution for example 10. So we're going to choose 2xy and the fifth root of 6xy, so it's going to be E. That's it for example 10. For example 11, write the center from the equations with the given. We have the center and we have the radius. So for example 11, the standard, we have the center is 3, 1, and we have the radius equal 7. So the standard form is x minus h squared plus y minus k squared equal r squared. So this is h, and here is k. So it will be x minus 3 squared plus y minus k is 1 squared equal 7 squared. That means it's going to be x minus 3 squared plus y minus 1 squared equal 4, 9. That's it for example 11. So we're going to choose x minus 3 squared, y minus 1 squared equal 49. So we're going to choose A. For example 12, use the properties of radical to simplify. Let's simplify this, the fifth root of 64x to the power 5. So the fifth root of 64x to the power 5. So let's check how I'm going to simplify this one. 64, I'm going to write down is 32 times 2. Because 32, I can write it down as a 2 to the power 5 times 2. So now 64 is going to be the fifth root of 64, which is 2 to the power 5 times 2, and x to the power 5 here. Now we're going to convert this one to the rational exponents. So it's going to be 2 to the power 5 times 2 times x to the power 5 and everything to 1/5. Now we can distribute the exponents on each one. So this one is going to be equal 2 to the power 5, 1 over 5. And the second one is going to be just 2 to 1 over 5. And the third part, which is x to the power 5 to the power 1 over 5. Now let's multiply because we can multiply the exponents. So this one is going to be 2 to the 5 over 5. And we can't do anything here, so keep it 1 over 5. And here is going to be x to the power 5 over 5. So this one is going to be 1. This one is going to be 1, and this one is still under the root. So the result is going to be 2. This one is outside the root. This one is still under the fifth root of 2 and x by itself outside the root. So that's it. For example, 12. So we're going to choose the first one. Is exactly what we get. For number 13, this is the solution. For number 13, we need to convert from the radical form to the rational exponents form. So the rule is from radical, if you have n and here is x to the power m, it's going to be, here is the rational exponents, is going to be m divided by n. Now we need to convert 3.5. 3.5. It's a square root. That means the number here is 2. To convert that is just going to be 3.5 to the power m is 1 and n is 2. So to the 1 over 2. That's it. This is the solution for 13. So we're going to choose D. That's it for number 13. Let's check number 14, how we're going to solve this one. We have negative 1 over 64 to the negative 1/3 without using calculator. So I'm going to, here is the negative sign out. The first thing what I'm going to do here, I'm going to take the 64 because here is the exponent 1. I'm going to take it on the top. So I'm going to use this rule. If I have 1 over a number with positive exponents, I can write it down the number with negative exponents. So I have 1 over a number with positive exponents. So this one is going to be the number 64 with negative exponents to 1/3. Now I'm going to use another rule. It says if you have a number with n and m, is going to be the same thing, the number n times m. That means you can multiply the exponents. So this one is going to be negative, and here is 64. Negative times negative is going to be positive 1/3. Here is the negative. 64, I can write it down as a 4 cubed, because 4 times 4 times 4 is going to be 64 to the 1/3. This one's going to equal negative 4. You can multiply the exponents, which is 3 times 1/3. 3 times 1/3 is going to be 1. So the result is going to be negative 4. There is many ways to solve this one. I just use the exponents of the rule to find the solution, how much it's going to be, because they ask you to evaluate without using calculator. For example, 15, we have the graph of f. Here is the graph of f. We need to find which one is going to be the graph of f x plus 1. So be careful on this one because we don't have the function f, but the difference between f and fx, like here's the function f of x or y equal f of x. So the difference, the graph of f of x, here's the graph of f of x. We need to find this graph. The difference between this graph and this one is exactly the same y coordinate, but x is going to be +1. So, or if you just these the points, you can add for each x coordinate, 1 is going to be the graph of the new function. Or you can say, here's the graph of f of x. We're just going to shift this graph 1 unit. Each x is going to be add 1 or shifted 1 unit to the left. So, but the easiest one to figure out, because you have the point here, you're going to take each point like -1 and 4 and change it to, you're going to add 1 here. So it's going to be 0 and 4. The second one is going to be, the second point is 0, 3. So it's going to be add 1 here. So we're going to graph 1 and 3. And the next point is a 3, 1, 3, 0. So it's going to be 4, 0. Going to be 4 and 0. And the last one is going to be 4, -1. You're going to add 1 here. So it's going to be 5 and -1. So when you graph these points, you're going to get the graph for the new function. So let's check now which one is going to be the right option. So let's go to the option. And you will see this option here. We have the point, the x is add 1. So the change from here's this function 0, 4 from changed from -1, 4 became 0, 4. And 0, 3 became 1, 3. So the next point is going to be 1, 3, which is this one, 1, 3. Then 4, 0, and 5, -1. So we're going to choose this one. That's it for this example.